This tutorial is to explain to you how to use Excel and formulas in Excel to calculate some basic descriptive statistics which summarize data from your experiments and observational studies. So we're going to use Excel to help us calculate the sample size, which we'll use the formula called count, and then the mean, which is what we call average in statistics, and it's symbolized X bar. We're going to use the function average. And then the standard deviations, sometimes abbreviated SD or just S. And we're going to use a formula STDEV, stand dev.s. There's going to be others, so these are the specific ones you want to use. Now, you should be able to, if asked on exams, calculate the mean. And there's the formula, sum of the values divided by n. And then we've gone over this earlier when we did lab exercise 1, how to calculate your sample standard deviation. It's this big formula here. We used the table to help calculate it, and we did it by hand with a handheld calculator so that you can see how standard deviation measures how variable the data is for a group that you're studying. And then we also did a significance test, and the significance test involved calculating ranges, which we call test ranges, that are calculated as a mean plus or minus 1/2 standard deviation. So I have two relatively small data sets that could be done with a handheld calculator. Sometimes data sets are larger. This data set, first one for volume, only has 5 replicates. The other one has only 7 replicates for each group. You can have data sets that are larger, 30 values, 60 values. So these formulas become even more important. The important part here is that you can use Excel to do this for you quickly and error-free as long as you've typed in your original data correctly. It's also important to note that on lab reports, I don't want to see the original data, so don't go turn in this as a table. You're going to only turn in the descriptive statistics for your group. So let's say we ran a basic experiment where you had one control group and one experimental group. That's why there's 2 columns here. Some experiments will have more than just 2 groups, and you would have to calculate mean and standard deviation for each one, and then report those in your lab report. Okay, so let's go ahead and use the formulas here. You would start by setting up your spreadsheet and typing in your data for each group, one column for each group. Okay, so group A or group 1, you put in all the values, make sure you don't type in with any errors, and then at the bottom is where you can go and calculate your sample sets. Of course, we know we have 5, but let's say it's a bigger data set. And sometimes you're doing replicates and something messes up in the replicate and you end up getting no data, so you would leave that particular case blank. And so when you do that, if it's blank, Excel won't count it. So let's say if we were missing this replicate number 3 here, you can see how it counts it as 4, okay? Because we've highlighted all of those cells, but there's only 4 with values in there, okay? So then for the mean, we're going to type in equals and then average, and make sure you pick the right one, okay? And then make sure you only highlight your values here. I might accidentally go down and highlight the sample size there where number 5 is in the cell. Only highlight your data, okay? And there's my mean, 5.14. Then we want to do the standard deviation, and so that's equals, and then start typing it in. STD and then E and so on. And so already Excel's giving me choices here. You can go and pick and double click on standdev.s for the sample. Don't pick the P or any of the other ones there. Now let's open up the parentheses, and I'm going to go highlight that same data again. Don't accidentally highlight the values below there because those were calculated values. Only your original data. You can see there with many decimal places, 0.77 is my standard deviation. Now, in order to do the significance test range, for the significance test, our test range, we have to take the mean and add 1/2 the standard deviation for your group. The little sub n there stands for n. They're in the formula here in the bottom left. And then in order to get the low value on the range, we're going to subtract 1/2 of that standard deviation. So we need to know what 1/2 the standard deviation is. So I'm going to take the standard deviation. I'm going to hit equal sign. I'm going to do a calculation. So I'm going to take the standard deviation here. I'm going to highlight it there. And that tells me I'm going to take whatever's in cell E10, I'm going to multiply it by 0.5, which is half. And that gives me half of the standard deviation. Now, down here where it has the test range, I have the top value is for my high value on the range. That's the mean plus 1/2 standard deviation. And then here is the mean minus 1/2 standard deviation. Those are the test ranges where we want to see. The means will always be different, but we want to see is, are they significantly different? And we want to see if, when we compare the groups, do those ranges overlap? And what I mean by overlap is, do they share similar values? If they do not, then the means are judged to be different. If they overlap, then the means are judged to be similar. And that's where we're testing the null hypothesis that we covered back in lab 1. So here all I have to do is just hit equals, go to my 1/2 standard deviation, because I got to add that, and I'm going to add that to the mean. Okay. And so that's taken my mean and added the 1/2 standard deviation, and there's my high value for the range. And then I have to subtract. So I'm going to say equals, I'm going to go highlight the mean and subtract the 1/2 standard deviation there, and that's my low value. Now, there's rounding rule. If you get a lot of decimals like we have here for the mean and the standard deviation and any of these other calculations, the rule is you always round to only one more number place from where the original data was recorded. Since the original data was recorded here to the 10th place, then we want to round to the 100th. So I'm going to go ahead and highlight all of these. I'm going to go to the home here, and there's a couple of buttons here that allow me to change the number of decimal places. And it jumped all the way down to 0, so I'm going to go ahead and click it up to where I am to the 100th place, because the original was to the 10th place. Okay. Now, once I've done that, let's say I have another group that I need to calculate the values for. Same number of replicates. I have putting them there to the right. And then another experimental group here, and I just have n for whatever, how many groups I have. I could have 4 groups, 5 groups, or so on, and I would have the same number of columns there. All I have to do is highlight here. Then I can either right-click and copy, or you can hit Control-C and that copies it. And then all I got to do is come in, highlight the cells that I want to copy those values. And let's say I had values there in that last column where it says experimental group N. And then I just paste, and it'll paste the formulas, and it'll run the calculations for those columns there. Right here, the last column is not giving me any values because there were no values in that column there. But that's how it's done real quickly. And then in your report, you would report the sample size for each group, the mean for each group, and the standard deviation for each group. And then you can tell, is there a significant difference or not? So let's take a look here. The low value for the high mean, this one is the high mean, the low value is 4.75 milliliters, but the high value for the other one is 3.65. So this value here doesn't reach, for the second group, doesn't reach within the range of the other group. So the two ranges don't overlap, so there would be a significant difference there. And then you can actually make a graph to show those ranges. Now, to show you how quickly this goes for our other group, I'm just going to do it not without explaining very much. I'm just going to do the count function here. Highlight my values. And I'm going to do the average. Highlight the values, hit enter. And then my standard deviation, STD, and then I'm going to go pick the one that says with the .s. Make sure you do the .s one. Highlight, enter. There's my standard deviation. Now to get the 1/2, just multiply the standard deviation times 0.5, and that'll give you half of it. And then we can calculate our test range values, the high and the low value. So we hit equals. You get 1/2 the standard deviation plus your mean. And then for the low value, take your mean and subtract 1/2 standard deviation. And there's your test range there. Now all I have to do is highlight, Control-C to copy, and then however many groups, I'm just going to go and highlight all the groups. Let's say I had several groups, like 10 groups or whatever. I can just go highlight and then paste the formula there and all of the values for all of the columns. Again, I only showed 2 here, but and then we want to follow the rule for rounding. If we look at the original data set, in each column, the original values here were recorded to the ones place. We want to go one more place past the decimal, past the original data set. Since this is the ones, then we're going to round to the tenths place. Okay, so make sure you round your calculations properly. Now remember, you never report your original data. You keep it for your records, but in science reports and so on, you report just the descriptive statistics. So here you would be reporting just those right there. And then you can see, well, was there a significant difference here? And we look at these ranges and ask, do they overlap? The higher average is the second treatment here. It's higher than this one, but are they significantly different? And that's where you go and look at the test ranges here. And you can see that the highest value here does not reach the range, within the range there. So in this case, there would also be a significant difference between the means.